This video is going to be a brief demonstration of how to use the browser-based software DAGitty to create and analyze directed acyclic graphs, otherwise known as DAGs. So you can find DAGitty in any search engine. And you can just launch DAGitty online in your browser by selecting this Launch DAGitty, or we can click on this main link. And you can see on this page there's some background information on DAGitty and how to appropriately cite the software, other similar programs, some updates on the right-hand side. If you click on the Learn tab, you can find additional resources on relevant topics, recommended reading. I'm going to go back to that main page. You can also download DAGitty's source for using the program offline. Today we're just going to launch DAGitty online in our browser. And you can see that this is a pretty simple point and click interface, so you can just click on any of these variables and move them around. To orient you to the key information on this page, you can see across the top that we have a toolbar with some helpful information. So if you click on the Model tab, there is the option to select a new model, to load existing models from DAGitty.net, to export your created DAG as a PDF, PNG, JPEG, or SVG if you're going to produce a figure for accompanying a manuscript. There are also some examples of existing DAGs in case you want to play around with some of these for more information. Several of these are cited in the literature, so you can also turn to the relevant manuscript for more information explaining these variables. There's also this really important How-To tab. So this is where you can go if you forget how to do something in DAGitty. So if you want to add a variable, rename a variable, delete a connection or add a connection, you just click on this tab and it will let you know the instructions for how to do that in DAGitty. So if you were to add a new connection, you would just double click on the start variable and on the end variable, or it tells you what key you can press on your keyboard. On the left-hand side, the key piece of information I want to call your attention to is the legend. So the legend indicates in colors the kind of variable you're looking at in DAGitty, in the DAG that you've drawn. So our exposure is labeled in yellow with this little play icon, and the outcome is labeled with this eye in the color blue. And then ancestors of the exposure are indicated by this yellow variable. Ancestors of the outcome are indicated by this blue variable, and ancestors of both the exposure and the outcome are indicated by a pink variable. Adjusted variables are indicated as white variables with this black outline. You can make a variable unobserved or latent by graying it out. And other variables are this darker shade of gray. Paths are also indicated by color, so a causal path on a DAG between the exposure and the outcome would be labeled in green, whereas a biasing pathway is indicated by a pink line. On the right-hand side, you can see under this causal effect identification panel that the minimally sufficient adjustment set options for estimating the total effect of an exposure on an outcome will be listed in bullet point form in this panel. So each bullet is a different minimally sufficient covariate set that you could adjust for to estimate the total effect of the cause on the outcome. So any of those sets would block all the biasing pathways between warm-up exercises and injury. And then if we scroll down on the right, you can also see that there's model code in this bottom panel. And this code changes as you modify your DAG. This code can be copied and saved elsewhere so that you can return to DAGitty and not have to recreate your DAG model every time you want to work with it. So instead of updating the existing DAG that we have here in our window, we're going to create a new model based on the figure 1 from our manuscript. So to do that, we're going to click on the Model tab and select New Model. And it asks us to enter the name of our exposure variable, which in our figure 1 was just X. We type in X and click OK. And then it asks us to enter the name of the outcome variable, which in our figure is Y. And you can see now DAGitty generates the causal path that we're interested in estimating between X and Y. And in our figure, we actually didn't hypothesize that there was a direct effect of X on Y, but rather an indirect effect through a mediating variable M. So to create this mediating variable in DAGitty, we just double-click the open space, type in M for this mediating variable and click OK. And then to create connections between variables, we double-click the start variable. So here we would double-click our exposure X, and then double-click our mediator to indicate that X is causing M. And then to continue this causal path, we would double-click the start variable M and indicate that it affects the outcome variable Y. So now we've created our indirect causal path that we want to estimate. And because we didn't hypothesize this direct path, in order to get rid of it, we just double-click the starting variable and we double-click the outcome variable. And now we only have this indirect causal path that we hypothesized. So once we've indicated the hypothesized direction of this causal effect, we are going to add our biasing backdoor path by adding covariate C1 and covariate C2. And we hypothesized that C1 was affecting our exposure X, so we double-click C1 and then double-click X. We hypothesized that C2 was causing our outcome Y. And we also hypothesized that the covariate C1 was affecting C2. So now that we've indicated all of these connections, DAGitty recognizes that this path between X and Y through C1 and C2 is a biasing backdoor path, which we can tell because this path has now changed to a pink color indicating a biasing path. Our code has been updated in the model code panel, and our minimally sufficient adjustment set options have been updated, indicating that either controlling for C1 or C2 would block the biasing non-causal path between X and Y while leaving this causal path open. Now we're going to add the other path that we hypothesized in our figure 1. We're going to double-click the space to add C3. We're going to add variable C4. And we're going to add variable C5. And we hypothesized that covariate C3 affected our exposure. We hypothesized that C5, I'm going to double click again, affected our outcome. And then we hypothesized that both of these variables were affecting C4. And so what you can see here is that the color of this path did not change to pink. So DAGitty recognizes that this pathway, this potentially biasing pathway, is blocked by a collider C4, which is considered an other variable on our DAG. And so our adjustment set did not change. We could still block the only biasing non-causal path on our DAG by either controlling for variable C1 or variable C2, because variable C4 is blocking this non-causal path on our figure. So while our model code has changed, our minimally sufficient adjustment set options have not. You can recognize that DAGs can get much more complicated than this quickly. So in order not to have to recreate a DAG every time you launch DAGitty, you can copy the code from this model code box and save it. And then you can go to existing code, paste it into the model code window, and update your DAG. So I've pasted in the code from the DAG that we used in our motivating example in the accompanying manuscript. And so here you can see all of the hypothesized paths, the causal effect of perceived parental smoking on smoking identity, both direct and indirect through a lagged adolescent smoking identity variable. As we describe in the accompanying manuscript, we tried to lay out the relevant variables in approximate temporal order from left to right, with the variables we assume to be more stable over time on the left, all of these, and the outcome on the far right. You can see that as we mentioned in our DAG checklist, that DAGitty identified 3 minimally sufficient adjustment sets for estimating the total effect of perceived parental smoking on adolescent smoking identity. So here are the 3 minimally sufficient adjustment sets. And we used a data-driven approach to select one of these covariate sets on which to condition for our specific analysis. If, for example, our study had already conditioned on a variable during the study design phase, let's say we restricted our study to only one specific school, and so we wanted to indicate to DAGitty that this variable was already conditioned on, already restricted, we could tell DAGitty that this is an adjusted variable. And to do that, we would select the How To tab. We can select How to adjust for a variable. And the instructions indicate that to toggle adjustment for a variable, you move the mouse over that variable and press the A key on your keyboard. So we just hover our mouse over school attended and select A. Now school attended is listed as an adjusted variable on our DAG. And the minimally sufficient adjustment set options have been reduced to the 2 covariate sets that included school attended to indicate that this variable has already been conditioned on and must be included in our covariate set. School attended is also bolded to note that this variable does not need to be further controlled for in the analysis because it has already been conditioned on in our study design. If you need any further help using DAGitty, there is a manual made by the creator of DAGitty in the Help tab, so you can find further information on using the program. To conclude, we're going to export our model as a PDF. So we click on the Model tab and select Export as PDF. And now we have a figure that's ready to inform our next research study.